Good evening, all of you. My topic is basic nutrient requirements and criteria for the choice of raw materials. First, basic nutrient requirements. The use of a good, adequate, and industrially usable medium is as important as the deployment of a suitable microorganism in industrial microbiology. Unless the medium is adequate, no matter how innately productive the organism is, it is not possible to harness the organism's full industrial potential. So, that means if the media is not sufficient, even though we use highly efficient strain of organism, it cannot use its full industrial potential. Indeed, not only may the production of the desired product be reduced, but toxic materials may be produced. Liquid media are generally employed in industry because they require less space and are more amenable to engineering processes and eliminate the cost of providing agar and other solid agents. We know that agar is a solidifying agent. So while we are using liquid media, there is no need of adding these agar, and also it requires less space and are more amenable to engineering processes. Aerobic fermentation are depend on a continuous input of molecular oxygen, and even some anaerobic fermentation require initial aeration of media, as in the case of beer fermentation. Then all microbiological media must satisfy the needs of the organism in terms of carbon, nitrogen, minerals, growth factors, and water. In addition, they must not contain materials which are inhibitory to growth. It would be essential to perform a complete analysis of the organism to be grown in order to decide how much of the various elements should be added to the medium. Carbon or energy requirements are usually met from carbohydrates, notably in laboratory experiments from glucose. More complex carbohydrates such as starch or cellulose may be utilized by some organisms. Energy sources need not be limited to carbohydrates but include hydrocarbons, alcohols, or even organic acids. In composing an industrial medium, the carbon content must be adequate for the production of cells. Nitrogen is found in proteins, including enzymes, as well as in nucleic acid. Hence, it is a key element in the cell. Most cells would use ammonia or other nitrogen salts. Any nitrogen compound which the organism cannot synthesize must be added to the medium. Minerals form component portion of some enzymes in the cell, and it should be present in the medium. The major mineral elements needed include phosphorus, sulfur, magnesium, and also iron. Trace elements required include manganese, boron, zinc, copper, and molybdenum. Growth factors include vitamins, amino acids, and nucleotides, and must be added to the medium if the organism cannot manufacture them. So all the components that the organism cannot manufacture should be added to the medium. Then this is a table showing the amount of various components required for the growth of bacteria, yeast, and molds. Carbon, which is required 48% for bacteria, yeast, and molds. Nitrogen, which is required 12.5% for bacteria, 7.5 for yeast, and 6 for molds. Protein, which is required 55% for bacteria, 40 for yeast, 32 for molds. Carbohydrates, 9 for bacteria, 38% for yeast, and 49 for molds. Lipids, 7 for bacteria, and for yeast and molds, it is required only in 8%. Nucleic acid, which is required 23% for bacteria, whereas 8% for yeast and 5% for molds. Ash required 6% for bacteria and also for yeast, but only 4% for molds. Then the minerals like phosphorus, sulfur, magnesium, potassium, sodium, iron, and zinc, copper, manganese should be needed in these amounts for all three organisms. However, detailed investigation is needed to establish the most suitable medium for an industrial fermentation process. But basic requirements like carbon nitrogen sources must be met by any such medium. The media adopted also depend on the scale of the fermentation. For small scale laboratory fermentation, pure chemicals are often used in well defined media. But this is not possible for industrial scale fermentation processes simply due to cost, as media components may account for up to 60 to 80% of process expenditure. Industrial scale fermentation primarily use cost-effective complex substrate where many carbon and nitrogen sources are almost undefinable. Then criteria for the choice of raw material used in industrial media. First one is the cost of the material. The cheaper the raw material, the more competitive the selling price of the final product will be. No matter, therefore, how suitable a nutrient raw material is, it will not usually be employed in an industrial process if its cost is so high that the selling price of the final product is not economic. So, if the cost of the raw material is so high, it will influence the final cost of the product. So using a cheaper raw material is more economical. For example, in penicillin production, lactose is more suitable than glucose due to its low utilization rate. But glucose is commonly used. Glucose is added since due to the cost issue. When we use glucose, glucose is used intermittently to reduce the acid production. Then ready availability of the raw material. The raw material must be readily available in order not to halt the production. If the raw material is seasonal or imported one, then it must be possible to store it for a reasonable period. The material being used must be capable of long-term storage without concomitant deterioration in quality. So, in order to store this raw material, we need to have large storage depots, and we should able to keep this raw material without any deterioration in quality for a long time. There should be no any attack of rodents, insect like etc. So it should be stored so we can control the ever rising cost of raw materials. Then next one is the transportation cost. Proximity of the user industry to the site of production of the raw material is a factor of great importance, because the cost of the raw material and of the finished material and hence its competitiveness on the market can all be affected by the transportation cost. If the cost of transportation is too high, it will affect the cost of the raw material and also the cost of the final product. The closer the source of the raw material to the point of use, the more suitable it is for use, if all other conditions are satisfactory. Next, ease of disposal of waste resulting from the raw materials. Waste materials often find use as raw material for other industries. Spent grains from breweries can be used as animal feed, and also corn steep liquor, which can be used in penicillin production, which is actually a byproduct of starch industry. Then molasses, which is a byproduct of sugar industry, which is obtained by cane and beet sugar production. But in some cases, no further use may be found for the waste from an industry. Its disposal, especially where government regulatory intervention is rigid, could be expensive. While we are choosing a raw material, therefore the cost, if any, of treating its waste must be considered. Then uniformity in the quality of the raw material and ease of standardization. The quality of the raw material in terms of its composition must be reasonably constant in order to ensure the uniformity of the quality in the final product and for the satisfaction of the customer and his or her expectations. In beer industry, information is available on the quality of the barley malt before it is purchased. This is because a large number of barley malt producers exist, and the producers attempt to meet the special needs of the brewery industry and also their main customer. Molasses, which is a major source of nutrient for industrial organism, is a byproduct of the sugar industry, as we have already mentioned. Where it is a byproduct, so it is a waste product from the sugar industry. So sugar industry is not as concerned with the constancy of the quality of molasses as it is with that of sugar. Each of molasses must therefore be chemically analyzed before being used in a fermentation industry in order to ascertain how much of the various nutrients must be added. As raw material with extremes of variability in quality is clearly undesirable as extra costs are needed. Then adequate chemical composition of the medium. The demands of the microorganism must also be met in terms of compounds they can utilize. Most yeast utilize hexose sugar, whereas only a few will utilize lactose. Cellulose is not easily attacked and is utilized only by a limited number of organisms. Some organisms grow better in one or the other substrate. Fungi will readily grow in corn steep liquor, while actinomycete will grow more readily on soybean cake. Then presence of relevant precursors. The raw material must contain the precursors necessary for the synthesis of finished product. Precursors often stimulate production of secondary metabolites either by increasing the amount of a limited metabolite or by inducing a biosynthetic enzyme or both. These are usually amino acid, but the other small molecules also function as inducers. The nature of the finished product in many cases depends to some extent on the components of the medium. The next point is the satisfaction of growth and production requirements of the microorganism. Many industrial organisms have two phases of growth in batch cultivation. First phase is the phase of growth or the trophophase, and phase of production or the idiophase. In the first phase, cell multiplication takes place rapidly with little or no production of the desired material. It is in the second phase that the production of the material takes place, usually with no cell multiplication and following the elaboration of new enzymes. Often, these two phases require nutrients or different proportion of the same nutrients. The medium must be complete and it should be able to cater for these requirements. For example, high levels of glucose and phosphate inhibit the onset of the idiophase. Then crude substrates provide initial cost savings, but their high levels of impurities may necessitate more costly and complex recovery and the purification steps downstream, and possibly increase waste treatment cost. Also, the physical and chemical properties of the formulated medium can influence the sterilization operations employed. A medium that is easily sterilized with minimum thermal damage is vitally important. Thermal part can also produce potentially inhibitory byproducts that may also interfere with downstream processing. Then it must be remembered that the medium selected will affect the design of the fermenter to be used. For example, the decision to use methanol and ammonia in the single cell protein SCP production developed by ICI PLC necessitated the design of the novel fermenter design. ICI is a chemical industry, and they try to use methanol and ammonia in single cell process. So it necessitated the design of the novel fermenter, which is designed by McLean and et al. In 1973. Equally, if a fermenter is already available, this will obviously influence the composition of the medium. That's all about the